Okay, let's ponder the homework then from Friday. This is problems 5, 6, 8, 9, and 10 in chapter 24. 5 should be pretty self-explanatory, combining the parallels and then going into series with the other resistor. So on number 6, you're looking at a light bulb plugged into an extension cord, and the two wires have individual resistance also. So the bulb doesn't get the full 75 watts because some of the power is dissipated across the wires. So then part B, when we redraw the circuit, we would draw those two wires as two small resistors, each of 0.8 ohms, that would then be in series with light. So you have three resistors in series that you can combine to find the total resistance. Then in part C, looking at the powers, the total power of the circuit, P is equal to V times I, the voltage delivered by the battery, and then the current, so 75 equals 120 volts times I. We can solve down for the current, and that's the current that goes to everything. Once you have that, then you can figure out what the resistance of the light bulb is with Ohm's law. V is equal to IR, where that resistance is just the three resistors in series. So the unknown R comes into there. And so the bulb resistance is 190.4 ohms. And then from that, we can find the actual power dissipated across the bulb using power equals I squared R. 0.625 amps squared times 190.4 ohms gives us 74.38 of the 75 watts is dissipated across the bulb. So only a little bit is lost across the cords. Problem number 8. This is more of a logic one. You have one circuit with a battery and a single bulb, A, and a second identical circuit, except now it has two bulbs, B and C, and they're in series. Total currents, Ohm's law, I for the first circuit, EMF over R. I for the second circuit, EMF over 2R, because the resistance is add. Based on that, we can reason to the brightness. The brightness is caused by the current that is flowing. You can't get a brightness only from a voltage. You can get a brightness once you use that voltage to cause charges to flow, which means brightness is an indication of current. So then the brightness is directly follow the current values from above. B and C will get exactly the same current, and it'll be less than what A got. Therefore, B and C will be equally bright, but then less bright than A, with less resistance in the first circuit. Then more total current flows through the circuit. A gets more total current, and so A is brighter than B and C, which are equal to each other. First thing you're going to have to do on number 9 is to redraw the circuit so you can see the two diagrams, the one from the book and the way that I've redrawn it there. Basically, your battery is in series with the 10 ohm resistor that is at the very top, and then everything else is connected to each other by the junctions there by A and B. So we can slide the vertical 20 and 5 around the sides, down to the bottom, and A and B with them, and turn those three into a parallel circuit of their own that is then in series with the very top 10 ohm and then the battery. From there, if we want to calculate the current across the 20 ohm resistor, then we break the circuit apart like we've done before. Equivalent resistance of the parallel, 1 over R is 1 over 10 plus 1 over 5 plus 1 over 25. Calculate that equivalent resistance for the parallel, and then once you have that, combine it with the other 10 that is hanging out there in series to get an equivalent resistance of 12.94 ohms. And then the total current, Ohm's law, EMF over R, that's the 25 volts from the battery over the equivalent resistance of 12.94 ohms to calculate the total current of 1.93 amps. Focusing then in on the parallel where that 20 ohm resistor is, Ohm's law, V equals IR for the parallel. I, the 1.93 amps times the equivalent resistance for the parallel, the 50 over 17, gives you 5.68 volts across each branch in the parallel. And then I20, since in that branch it's along with a 5, that's going to be V over R for that branch, 5.68 volts divided by 25 ohms, or 0.227 amps. In number 10, you're basically coming up with a 45 ohm total resistance and a 35 ohm, and there are different combinations you can do there. I've shown a couple that will produce those, but there are a number of different combinations.